checking the workbook homework from last night, and we're looking at number 3, and we already know that our solutions are 4 and negative 2/3, okay? But if I wanted to put this on paper, then let's check 4 first. And I would have 4 plus 10 over 4 squared minus 2 is equal to 4 over 4. Do you guys agree? All I'm doing is just checking my answers. And that's going to give me 14 over 14. What's 14 divided by 14? 1. Is 1 equal to 1? Yes. Okay? That's probably not the one I should have checked. Okay? Negative 2/3. Don't flip out. Calculator. Lindsay, do you mind cutting my calculator on for me once I get it there? I don't understand why it won't cut on for me. Maybe it doesn't like me. It only likes you. Okay. All right, you gotta be a parentheses ninja. So here we go. Let's check this 2/3 because I don't want to do two. I don't want to, and it's a fraction, and I embrace fractions. I still don't want to deal with it though. Remember that we have p plus 10. Let me put it over here. P plus 10 over p squared minus 2 equals, was it 4 over p? Was that the original? Okay. All right, so here we go. Parentheses. I want to keep my numerator together. 2/3. All right, so I'm going to keep my numerator together, but I want to separate my fraction, so I'm going to put another parentheses. Negative 2 divided by 3, there's my negative 2/3, okay? Plus 10. Now I have closed in my numerator, okay? And now I'm going to divide it by parentheses. Getting rid, that's for my denominator. And I'm going to take negative 2/3 and I'm going to square it. And actually, I'm going to put another set of parentheses in there because I want to separate that negative 2/3 squared. I told you I love parentheses. It's like a hug. I love hugs. Okay, minus 2. And I'm closing my denominator. It equals negative 6. Okay. That's my left side equals negative 6. My right side better equal what number? It better equal negative 6. Oh, Lord, please let it equal negative 6. 4 divided by my numerator divided by my denominator, which is negative 2/3. If you use parentheses correctly, then you can check every one of these in the calculator. But you have to be really, really careful. Okay? Does that help? Are you sure? Okay. Do you need to see another one? No? All right. Any other questions on the homework assignment? Yes? Number 4? Yeah? All right, so let's look at number 4. Number 4 was S over S plus 2 plus S equals 5S plus 8 over S plus 2. All right. A couple of different ways to solve this problem. You got an S over there, okay? Somebody come in, I don't remember who it was, somebody come in this morning, they go, look at this problem and see if I'm on the right track. I solved it a different way, and they solved it a very easy way. Do you notice anything? Now, this is when I have to force myself to not be a what? I've got to force myself to step back and become a farce person. I got to look at the big picture. What do I have going on here that might be beneficial to me? I have like denominators. Okay. I know that when I have like denominators that if I get them together, then I can make it one fraction or one numerator over one denominator, right? So if I've got that s plus 2 thing going on, what do you think I should do to this term on the left, s over s plus 2? What should I do? Move it. Move it, because when I move it, what's going to happen? It'll be able to combine five s plus 8 over s plus 2 minus s over s plus 2. I've got like denominators, folks. Can't I put this as one numerator over one denominator now? This is the easiest way to solve it. I didn't solve it like it's on my paper. Not until I saw it this morning. Somebody else saw it this way. What can I do with the plain old s? Over 1. Put it over 1. Because I can write any number over 1 and it won't change its value, right? And now, 5s plus 8 minus s over 1 denominator of s plus 2. Right on? Simple so far? What else do I have going on that right side? Like terms in my numerator. So I'm going to take 5s minus s, which gives me what, y'all? 4s plus 8 over s plus 2. I hate using s as a variable because my s's look like 5s and they're not very pretty. What can I do now? Why can I cross multiply? Because I have a proportion. I have one fraction equal to another fraction. So here we go. This is the easy part. S times s plus 2 is equal to 1 times that thing, which is that thing. Right on? Yeah? No response. Distribute on the left. S squared plus 2s equals 4s plus 8. I ought to hear bells and whistles going off in my head. Why? What kind of term do I have there, y'all? What do I do? I have a quadratic. How do you know I have a quadratic? I have a squared term. Now, we just come out of a whole unit of x squared equations. What do I need to do to solve a quadratic equation? First and foremost, I have to set it all equal to what? 0. Now, do I want to move my s squared term to the right? No, because that's going to give me a negative leading coefficient. Dumb, 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 dumb. Doable, but don't do it. Move everything that's on the right to the left. And I'm going to subtract 8. It doesn't have anything to subtract with, but I am going to rewrite this in descending order. So my s squared minus 2s, because 2s minus 4s is 2s, minus 2s. I'm going to throw my minus 8. And now I have my quadratic equation equal to 0. Folks, how can I very quickly and easily solve s squared minus 2s minus 8? Factoring. Solve it by factoring. I know it's s and s. What are 2 factors of 8 that when I subtract give me 2? 4 and 2. Are my signs the same or different? They're different. And it's minus 4 plus 2. Right on? Are we cool? Now what? Set each factor equal to 0 and solve. And I've got 4 and negative 2 as my solutions. Do you guys agree with that? I'm sure you're calculating all of this. Okay? What now? I got to check it. I have to check it. If you look at this, where did I start? Can I check it here? Can I check it right there? What do you think? How many of you say, yeah, probably can? How many of you say, nope, cannot do it? How many of you say, I don't really know, just tell us the answer? Fair enough. What do you think? Even if you say, I don't know, which way are you leaning, yes or no? Talk to me. Probably so. All we've done is we've manipulated the original equation. So this is like having a $1 bill up here, and it's now been changed into 4 quarters. It's the same value, it just looks different, okay? Now, go either place. Look up here now. This is where excluded values help you. S plus 2 is our denominator. What value can S not be ever? Negative 2y. Because negative 2 is going to make my denominator what number? 0. And can I ever have 0 as my denominator? No, why not? Because it's an undefined value. So I don't even have to do any math. Can I keep both of my solutions? I definitely cannot keep which number? I cannot keep negative 2. And put yourself a note there. We'll make my denominator 0. And that's bad. Okay? That is the universal smiley face for bad. Are we done? No, we still have to check 4. Okay? Still have to check 4. So go up here and let's do some work. 4 over 4 plus 2, which is 6, plus 4. You guys agree with that? Yeah? I don't know what that number is going to be. I'll figure it out in a minute. 4. 5 times 4 is what? 20. 20 plus 8 is 28. And then 4 plus 2 is 6. Right on? All right, put it in your calculator. You can put 4, 6 plus 4. 2/3 plus 4 and 2/3. I know that. And then 28 over 6, which is 4 and 2/3 again. And you can check that in your calculator. I just added it in my head. I'm not a big fan of mixed numbers, but I can do that quickly in my head. Okay? Where'd I get the 2/3 from? So notice somebody's looking at it and going, where'd you get that? I just reduced 4 6 into 2/3. Does that help? Yeah? Any other questions? Awesome. Guys, you're looking at a test in probably 2 days. 2 or 3 days, which would make it Thursday or Friday. Really? I just went super saucer size. That was alliteration. What's that? Yeah. Are y'all? Hey. Time out. Go. All right. So we are going over section 7.7. Which is radical equations. I know how you guys love radicals, and that's why we're going back to, don't look at me like that, cutting your eyes at me. I know how you love radicals, so we can't leave them. We have to stay with them. We have to, all right? What do you have to do when you're solving this? You don't have to write this down. But when you were first taught how to solve x plus 2 equals 5, what were you told to do? Get the x by itself. Get the x by itself. Now, give me fancy talk for that. Isolate the variable, okay? So maybe I do want you to write this down. Isolate the variable. Radicals, of course, are the radicals. So if I were to give you something like the square root of y equals 5, what would you have to do if it weren't already where it needs to be? Wouldn't the same rules apply to radicals? Wouldn't we have to make sure to isolate the radicals? I mean, this one's already done for me. How do you solve that? Square root of y equals 5. All right. how do you undo a square root? You square it. So what you do to one side, you finish that statement, you have to do to the other. And I have the good fortune of having colors. So what is the square root of y squared? Y, isn't it? Okay. What's 5 squared? 25. Oh my Lord, that was difficult. Am I done? Am I done? What have we all had to go back and do? Check it. All right, so now let's check it. Square root of 25 equal to 5? Is that a true statement? Yep. Is y equals 25 my official solution? Yes, it is. Good answer. Nobody. Good. Thank you. All right, y'all. No, that's why I used colors. The original equation was square root of y equals 5. And then I squared both sides with my green. So this was my original equation. This is what I did to solve it. Okay? Don't you undo a square root with a square? Yes. What would you undo a cube root with? A cube. All right, so let's look at another one. Isolate the radical. It's very important. How about this one? What if I wrote it x to the 1/2 power plus 16 equals 0? It's just the square root of x. Rewrite. Rewrite the rational exponents as radicals. Or as, yeah, that's fine, as radicals. So I'm going to rewrite that. The square root of x plus 16 equals 0. And tell me what to do, y'all. You know what to do. Isolate the radical. How do I do that? How do I move the 16? Subtract it. So I get the square root of x is equal to negative 16. Megan, what you thinking? You tell me. Somebody tell me. Answer that question for me. Remember, the denominator is at the door. It's our index. So 2 house x1. Remember, and if it were the 1/3 power, how would I rewrite that? The cube root of x. Folks, is that possible? Can I have the square root of a number equal to a negative value? Can't. This is kind of weird. Let's square it and see what happens, okay? Because I have to square both sides, right? So the square root of x squared is x. And what is negative 16 squared? 256. Oh, okay, so my answer is 256. What do we have to do? Check it. Okay, check it. All right, what was my original equation? Folks, which one do I want to plug into? Plug into this one, okay? Don't plug into the 1/2 power. Hold that thought. You seeing it? Okay. All right, let me plug it in here. Check it with this one. So I have the square root of 256 plus 16 is equal to 0. What's the square root of 256? 16. So 16 plus 16 equals 0? What? Is that true? Nope. No. What's the square root of 256? 16, right? 16 plus 16 equal to 0.
But when is it just plus or minus?
Okay. All right, first of all, let's look at it this way. Is this a true statement? No. Even if I were to put that the square root of 256 was negative, think about it. Think about it. The square root of 256. Guys, that's just weird. When what? The square root of 256 is negative 16? Yeah? But think about it. Think about it right here. This one right here. This would be a star problem. This would be one of those special cases. One of those that you're probably not going to see on SOL. Can the square root of a number be equal to a negative value? Megan was looking like, what? Maybe you didn't realize you were doing that. Maybe I read it wrong. But when I wrote that square root of x is equal to a negative value, she looked at it like, huh? Is that possible? No, it isn't. Okay. This one is one of those weird cases, okay? Weird case of no solution. If you didn't figure it out here with this step, then when you check your value and you get false, this is a no solution. This is the same type of problem as working out those absolute value equations. An absolute value of something is equal to a negative number. And some of you jump on it immediately and go, no solution. And even if you got caught up into getting an answer, when you go back and check it, it's still going to be no solution. Okay? Yes? But if you, again, I still go back to this right here. Can you have the square root of something that's equal to a negative number? Because when I say, do you say, what's the square root of 4? You always, what's the square root of 9? You initially tell me what? Because we're taught, let me get you a better explanation. Because right off the top of my head, it's going to confuse you even more. Okay? Can you wait and let me dig to find a better explanation? Is that fair enough? Not for this. You'll see how this is going to work out. Okay? You'll see. Can you give me? Just watch. Just watch. I promise. Okay? All right, can we do another one? Promise it's going to work out. Promise. Here, let's do another one. Let's look at another one. Trust me. If you had the square root of a minus 4, that quantity, minus 3 equals 0. What are you going to do? You still have to what? You still have to isolate the radical. So in order to do that, folks, what am I going to do? I hope you said add 3. Okay. How are you going to solve that? You're going to square both sides, aren't you? Okay. Because what you do to one side, you have to do the other. What's the square root of the quantity a minus 4 squared? A minus 4. Didn't it just, when you square a radical, doesn't it just take away the radical? Guys, are y'all with me or no? When I take the square root of a minus 4 and I square that, does it not give me a minus 4? Okay. What's 3 squared? 9. Can you solve that equation? How many of you say, yep, a is 13? Am I done? No, what do you have to do? Check it. Okay? As bad as you hate to do this, and I do too, throw it in there. We get the square root of 9. Square root of 9 is what? 3. Minus 3, which is 0. Right on? We're talking about principal square roots. I'm not talking about the plus minus. The square root of 9. Whenever you first learned your square roots, you learned them as square root of 9 is 3. Square root of 16 is 4. Okay? We're talking about the principal square roots here. So it works out, yes? Yes or no? Okay? That's all it is to it. This is really, I mean, this is a one-day topic, literally, that you guys are like, oh, bring it on. Easy, easy, easy. Look at another one. Questions at all? Here's another one. How about this? -3 plus the square root of the quantity a minus 4, which is equal to 8. You do that one. Add 3. Why? Get the radical by itself. 8 plus 11 and 8 plus 3 is 11, right? What do I do now? Square both sides. What do I end up with on the left? A minus 4. 11 squared is 121. Add 4, we get what? A is equal to 125. Check it. Can I check it in the original? Yes or no? Yes. Can I check, now be careful, the square root of a minus 4 equals 11. Can I check it in there as well? Yes, you can. It's just a manipulated version of that first original equation. Now here's the thing. What if you made a careless mistake in this equation? First of all, you're probably not going to have the right answer anyway. But when you go back and check it, it's definitely not going to be right, correct? So just keep that in mind. Don't make a careless mistake here. Check it. I'm going to go to the original, -3 plus square root of 125 minus 4, which gives me the square root of 121, which is 11. And folks, is -3 plus 11 equal 8? Yes. So I know that I have the correct solution. Right on? Any questions? How many of you had that as your answer? Perfect. Excellent. All right, let's take it a step farther. How about this one? Cube root of 2y minus 1 equals 3. How do you solve that one? You don't need me to tell you what to do. Be very careful. Say what? Why are we cubing this one? Because it's a cube root. Exactly. And talk to me. What you do to one side, you have to do the other, right? Okay. How many of you had 2y minus 1 equals 27? Good. Keep going. All right, how many of you had y equals 14? Facile or difficile? Muy fácil, see? No? Did you cube it? Two y minus 1 equals 27. It's okay. You got to keep in mind, don't make careless mistakes. Because if you make a careless mistake in your manipulated version of an equation, then you're going to be wrong. Heard. How many of you checked it and you got it right? Hands up. Cool with this? You can check it in your head, but just don't make careless mistakes. Okay? I would not, you want to create good habits. The good habits take longer. Okay? Bad habits are checking in your head. I wouldn't do it. Calculator can be a beast sometimes. If it says to check on paper, then you need to check on paper. Fair enough? Fair enough? Okay. All right, here you go. Look at this one. 9 plus radical x minus 1 equals 1. Very good explanation, by the way. What do I do? Minus 8 from both sides. What did I say? Okay, I don't know why. My mind and my mouth don't work together. Do what? Oh, how come? Immediately, Paula's like, no, I ain't doing nothing else. Why, Paula? Because it's the radical equal to a negative number. All right, first person. How many of you saw it immediately, went, bless you, went, I ain't doing nothing else. Okay, I'm a tree people. Come on, get in the wagon. Here we go. What are we going to do to this? We're going to square both sides. I don't care if we're all in a wagon together. I'll be driving, so I'll be on the front seat. Negative 8 squared is what? Bless you. 64? Right, Christian? You got this? Oh, all right. How? Wow. So what am I going to? I'm not writing it down. I already know. Okay. Fair enough. I'm going to check it on paper. Because if I don't, I may not already know that the answer. Here we go. 9 plus. Square root of 65 minus 1 is 1. 9 plus square root of 64. 9 plus 8. 9 plus 8 equals 1. No. No. Nuh-uh. False statement. So what is my solution? This is a no solution. But what is x equals 65? We got a value. It has to be something. What is it? It's an extraneous solution. Okay? Let's do this. It is an extraneous solution. Because it's not, it ends up being a false statement. Okay? What do you think? Some of you are going to see it because you are farce people. I so envy you. I get caught up in the algebra and I want to move this, move that, square this, square that, and solve this. I'm just envious. That's all. I wish I could back up and see things. But I'm having to force myself to do that. Okay? There are others of you like me, so don't act like it's not. One more, or maybe two. Is this 7? All right, here we go. How about this one? The square root of y minus plus 5, y plus 5, is equal to the square root of 2y minus 3. Just square both sides. That's all. Square both sides. Okay? What you do to one side, you have to do to the other. That gives me y plus 5 equals 2y minus 3, right on? Yep. I'm going to subtract y, and then I'm going to add 3. Did you get 8 is equal to y, or y equals 8? How many of you had that? All right, did you check it on paper? How many of you checked it on paper? There we go. How many of you checked it in your head? Look. Here we go. I'm going to throw it in the original. 8 plus 5 equals 2 times 8 minus 3. Square root of 13, square root of 16 minus 3. Guys, square root of 13 equals square root of 13? Yep. So I have a solution right on. Fossil. Isn't this easy? This is so easy. The thing you got to check, or the thing you have to be sure that you do in the end, is just to check. This is the last example. If you were to have the quantity t minus 3 raised to the 1/3 power equals 2. What do I do to that? It's cube root of what? The whole thing. Cube root of t minus 3. Now, did we really have to do that? We could have just cubed it. We didn't really have to rewrite it as a cube root, but it's okay that you did. So what are we going to do to both sides? That's right. Cube both sides. Because we're undoing that 1/3 power, or that cube root. And we get t minus 3 equals 8, yes? Add 3 to both sides, we get t is equal to 11. Yeah? And now we're going to check it on paper, right? Sneaky McSneakyston. 11 minus 3 to the 1/3 power. Or you could put under the cube root. What's 8 to the 1/3 power? Or the cube root of 8? It is 2, so we do have the correct solution. Questions, folks? Isn't this easy? I just want you to take a look at the clock. Okay? You ready for this? Page 95. Page 95. I want you to do 2 through 16 even. Show your work. Be sure you check your values. On paper would be best. But you always know best. Not the adults. Just saying. Okay? You may work together. You may work by yourself. It's totally up to you. Comprende?